I've got a heater here and it's operating on AC 240, and there's two elements in it. There's one, there's the other, and they have a resistance of 48. Elements can be connected in 3 different ways to provide 3 power settings of 600, 1200, and power equals 2400 watts. When the heater is used only with one element, what is the power output? Okay, so we want to find power. So power is VI. Power is also equal to I squared R, and power is also equal to V squared over R. So what have we got? We've got the voltage, and we've got the resistance. We're going to use this one here. Now when we're doing calculations with AC, we want it in the RMS. Okay, it's a big tick. We don't need to be timesing or dividing by root 2 in this case. We want it in the RMS, we don't want it in the peak or anything like that. So we're just going to use that guy there. So power equals 240 squared over the resistance of 48, because we're just looking at one. When you do that on your calculator, you get 1200 watts. In the second one, it says complete the circuit below to show the connections when the heater is set to provide a heating power of 600. So which is it set out when we want to find 600? So basically you can set this up in 2 ways. You can make this a parallel circuit. This is a parallel over here. And the parallel will look like that. Or we could have this series over here, and in terms of that drawing, we've got to do it like back around to the top, like that. So we're just going to work out now which way it's going to be set up. So let's do the parallel first. If we were talking about the parallel, we want to find the power, V squared over R. Well, if each of these, if we remember, is 48 ohms, and there's 2 of them in parallel, so we have 48 and 48. We have to find the total resistance if we want to use this formula. Now for those of you who have done enough practice, they'll know that when 2 things are the same, the total resistance is half, so the total resistance is 24. But let's just work this out just to prove it's the case. So in parallel, 1 over the total resistance is 1 over R1 plus 1 over R2, which equals 1 over 48. So 1 over 48 equals 2 over 48. So RT equals 48 over 2, because you flip it, and that equals 24. And that's what we got. So let's just put the number in now. So our voltage of 240 squared over 24, which gives 2,400. But they want the 600 one, so I think the answer is going to be series, but we'll just check. So it's not that answer, so it's not parallel. In series, we've got to do the same thing. P equals V squared over R. The total resistance, each one of these is 48 still, because it's written here. In series, you add them together, so the total resistance here is 96. 48 plus 48 is 96. So you put the values in. 240 squared over 96, and that equals 600. And that's the one we want. We want the series. So let's just join the lines up. Done.